Kinley, you completely missed that.
Okay.
Like it's a circus, like not a ribbon.
Oh, Leo, I was like halfway there. You're just gonna help me out that little bit. Maybe you should stop and try to be funny.
Well, I stopped being funny, like...
No, you're trying to be funny right now.
Day one?
Be like day one.
Oh, yep.
Day 0.
Is this the last, chapter that we're doing?
Yes, this will be the last complete chapter you do, seniors.
For seniors.
For seniors. Juniors will get through 8 also. Okay, hypothesis testing for the population mean. Again, note card's going to be crucial that you label it for which hypothesis test you're doing. So today we're going to do a hypothesis test for population mean with a large sample. And large sample means greater than or equal to 30. Oh.
Please, and I can't do a baby over here all alone.
Probably move over there.
I don't wanna be hard ass.
Okay.
You were always one.
I'm going to give you the steps first, I think, to the whole hypothesis testing. Do I want to do that first? No, I think I'm going to get this out of the way. Okay, the one skill you need to do is finding a critical value to separate your rejection region from your fail to reject region. So, example 1 is going to be find the critical value that separates the rejection region from the fail to reject region. Yes, we did. So because I've got large samples, what are my critical values going to be? We've got 3 kinds of critical values. We've got Z's, T's, and Chi's. Which ones apply with large sample and mean? Same thing as last chapter.
T?
Wrong.
Z.
These are Z's. So, these will be Z scores. And how do we get Z scores?
Why is it Z?
Large sample, mean. Okay? Z scores are found with inv norm.
Is that supposed to be part of the...
Nope.
So I don't...
Nope, inv corm. Inv norm. What do you feed inv norm?
Like, %.
Nope.
No, it's...
Area to the left.
Yeah.
It always ends up being half.
So, let's say we are doing a left tail test, and the alpha equals 0.10. A left tail test indicates that our rejection region is in the left tail. So left tail, left rejection region. Shaded is reject. And we're doing the normal curve, 0 in the middle. And we want to find this z-score here. And what I know is 10% is shaded here. And that means 90% is unshaded. So how are you going to get that z-score?
In norm of
Of?
0.90.
Incorrect.
Again.
0.1. Because you want the area to the left. So I'm standing on this z-score. What's to the left of me, Kenley?
Oh, to the left?
To the left. That's why I wrote left there. 0.10. What is the inv norm of 0.10?
Oh, it's -1.28.
Okay. If we're doing a right tail test with an alpha equal to 0.5, can you find that critical z-score? So again, it's important to make the graph. Oh, is that fast?
Yep.
Oh, I don't feel like I'm going fast.
You're not, I'm just really slow.
Oh,
Shocker.
so normal curve,
It didn't mean her.
0 in the middle. Right tail means my rejection region is on the right tail of the curve. The amount that's shaded is given by the alpha,
0.05.
0.05, which means the unshaded is
0.95.
0.95. So if I want this z-score, what are you going to feed inv norm?
0.95.
Very good. Because you want the area to the left of you. If I'm standing here, the area to the left of me is 95% of the graph. And what's that one?
1.64.
1.64. Positive, above the 0. Negative, below the 0.
Weird how that works out.
I mean, I know, tricky. Okay, two-tailed test. Alpha equal to 0.8. Which means we've got two rejection regions.
Were they,
How much is shaded in each one?
0.08.
0.0.
0.04.
It is 0.04 because you want a total rejection region of 0.8. So that puts 4% here, 4% here. What's in the middle?
0.
92% in the middle. Okay.
That's what I was talking about with the whole half.
Oh, that's the two-tail. You're going to cut it in half. Yes. So we're going to feed inv norm what value? 0.04. That will give us a negative z-score. What was it? Negative 1.75. Is it necessary to do another inv norm to get this one? What's it going to be?
1.7.
Positive 1.75. They are symmetrical. Any questions on finding the critical z-score? Okay.
so, Christine already gets two answers.
Correct. All right, now we're actually going to go through the steps of a whole hypothesis testing. And there are 7 of them.
Do you think half a page is enough or?
For the steps?
Yeah.
Yeah.
I don't even know.
Here's your steps. First one is to write the claim. Identify ho and ha. I should say right. Could have said right.
Right hole in there?
Yep. Write the claim, the ho, and the ha out.
Alright.
After that, you're going to sketch rejection region and find critical Z. With your inv norm.
Yes, good.
Okay. So sketch the rejection region and find the critical Z using your inv norm. Now you convert the sample mean into a z-score with this formula.
What's critical Z?
Critical Z, that's the one we just got done doing. This one's critical because it's separating reject from fail or reject, making it a critical Z.
Yeah, but isn't it still a
A z-score, yes. But we call this one the critical one. This one's going to be the sample mean.
Different. They're the same but different.
Same, turning them into z-scores, but not the same z-score. Okay. So we did this back 2 chapters ago when we had an x value and we turned it into a z-score to see where it fell on the curve. Okay, so the sample mean, to do this, you've done this before, take the sample mean, subtract the population mean, divide by the standard error, which is the sample standard deviation over the square root of the sample size.
Would it be easier to write it as a multiply by the square root of n over s?
Well, that's the way they do it, so I'll tell you. Do whatever you want. You can convert that. Okay? So now, once you've got your sample mean, what you're going to do is decide whether your sample mean falls in the unshaded fail to reject region or does it fall into the reject region. So now you're ready to make your decision. So step 4 is going to be to make decision. Reject the hoe. Or fail to reject the hoe. Oh, and I should have said this sample mean is from the hoe. Sample mean in the hoe, because we always test the hoe. But it's the same number in both the hoe and the ha, so it doesn't really matter. And then your last,
What does that mean?
I'll show you when we get to an example.
Okay, go home.
And then your last step is to say something about the claim. You're saying one of those bottom 4 things on the flow charts. So we call that interpret the claim. Interpret the claim. Where you're going to use that little 2-part tree diagram. So I got it down to 5 steps. That's good. So, here we go.
How many examples are you doing?
I have 2.
This is example 2.
Oh, yeah, I forgot about that. It's our first hypothesis test.
Or 2, and then we got another series.
No, it's just 2. 1 and 2 done. All right, let me see what we got here for words. 7, 2. Okay, the CEO of a firm claims
Oh, it's like I'm looking at me.
that the mean workday of the firm's accountants is less than 8.5 hours. So, you're going to test the claim. So, to test the claim, you take a sample of 35 workers, and you find that their mean workday is 8.2 hours with standard deviation 0.5 hours. You're going to test at alpha equal 0.01.
Or draw a graph.
Okay, nope. What was step 1?
It is.
Hard to claim.
Write the claim, identify ho and ha. So first of all, the key word in here, what he's making his claim about, is the mean. And we're going to have two sections that deal with mean, the big sample section and the small sample. Mean with 35 is big sample, so you're doing the Z section, so you'll come to this section on your note card. Okay? So, we're going to write the word claim out and say what the claim is, and use symbols. So his claim is that the mean workday for all of his employees, so mu, is less than 8.5. So is that the ho or the ha?
Is that?
It's the ha. So what will the ho be that we're actually going to test?
The mean.
Greater than or equal to 8.5. So we're going to test to see if the ho is true or not. Okay, that's step 1. What was step 2?
Sketch rejection region.
Sketch the rejection region. Which one tells me where my rejection region's at, the ha or the ho?
I think the whole.
You are wrong. The ha determines where the tail of the rejection region's at. So the ha tells me left tail.
Oh, from the thing.
Yep, and that was back from Thursday. The ha determines where your rejection region's at.
Okay.
So we're going to have a rejection in the left tail. And how much is shaded?
Uh, 8.5?
Try again. The 1%.
Okay.
Which means we've got 99% unshaded. Okay, so we sketched the rejection region. Now we've got to find the critical z-score. The critical one separates these two regions. So you're going to do the inv norm of what?
0.01.
Very good. Area to the left. A negative what?
Negative 2.33.
Okay. So step 2 is done. Now we're on to step 3. Convert the sample mean from the whole, which is 8.5, but what's in the ha also? 8.5. So you can't mess that up. So we're going to turn 8.5 into a z-score to see where it lands on this curve. So the z-score for 8.5 is, according to the formula, oh, not an 8.5. Oh, I wrote this wrong. Oh, no, I didn't. Not 8.2. My sample, 8.2. Sorry.
So should the claim be 8.2?
No, the claim is what he said. Now I've got a sample. I'm turning my sample mean into a z-score. 8.2 was my sample. This is my x bar. This is my S. S is 0.5. So it's 8.2 minus the mu. What's the mu?
8.5.
Oh, that's why. This was wrong. Get rid of that in the hole. That's what screwed me up. Get rid of that. Yeah, that was bad. It's not in the hole. The mu is in the hole. The sample mean is in the sample. The mu is in the hole. That's right. Oh, sorry. Just get rid of it.
Go back up really quick.
Oh, yeah. Yeah, when I said in the hole, it's the mu that's in the hole, not the x bar is in the sample. That's what I had wrong. I had it going to the wrong thing. So my,
We'll see what happens.
I know. Watch me, I'll get the second one right completely.
Okay.
So, 8.2 is the x bar. My mu is in the whole 8.5, because I'm trying to do x bar minus mu. X bar is the sample, mu is in the whole, 8.5.
Star is the sample mean.
Yep,
Okay. Are you recording?
yep,
Use your microphone.
I do. It's just on the white part of my shirt. And then it's standard deviation over the square root of the sample size. Standard deviation is 0.5.
Over square root of 35.
Very good. And now it's parentheses. So those that just sit here and write down the answers, forget that you need parentheses and don't get any of them right. Because you don't practice it. I don't feel sorry for you people.
Alright, I got an answer.
Got this open bag of Doritos on that thing that we came from.
I didn't do that though.
No, I'm thinking daddy's now.
I got negative 3.5.
I got a negative 3.55.
Okay, well, yeah, I mean, if you want to be like that. Yeah.
Okay, so where did the hole land on my graph?
That's the rejected hole right there.
Okay, so take a look. This is a number line. Here's 0. My critical was negative 2.33. My sample hole is in negative 3 point. Do you agree that it's back here in the shaded?
Yep.
So if you land in the shaded, what do you decide? Reject the hole or fail to reject the hole?
Reject it.
So we're going to reject the hole. Now I have to say something about the claim. So use your little flow chart thing, tree diagram. My claim was the ha. So I'm following the right side of the poster. Claim is the ha. We rejected the ho. So what can we say about the claim?
It's true.
The
Now,
claim
why
is
do you
true.
know that that's the claim?
What?
Why do you know that the ha's the claim?
'Cause that's-
Oh, it's always the claim.
No, because it just had a less than in it. No equal to sign.
The claim was the one against you.
Why are we rejecting the whole?
Because the negative 3.55 is in the shaded. See, the shaded starts at negative 2.33.
Okay.
Claim
The answer, just reject out.
is true. Two-part answer. It's a two-part answer. One for each part. 1 point for each part.
Why is the claim true?
Why is it what?
Why is the claim true?
Because you gotta follow this.
Yeah.
The claim was the ha. So we're over on the right-hand side of the tree diagram. See where it says claim ha on top? Follow the branch down that says reject ho. And what's underneath that one?
True.
Claim is true.
The reason we did ha is because it was left out.
Yes, because of the less than made it ha.
Wait.
This sign right here is what made it a ha,
Because it doesn't have equal.
because it doesn't have an equal to in it.
But the only reason, I'm saying the only reason why we chose that one out of the two is because it's the left tail.
Correct. Okay, try one more. We'll go through those 5 steps.
Is this our last thing?
This is it, Kenley.
Why do you have to say my name?
Because,
They might not know it. Oh, wow.
let's see, the U.S. Department of Agriculture report. Okay, so the claim being made that the mean cost of raising a child mean cost of raising a child from birth to age 2 is $8,390. You believe that this value is incorrect, so you select a random sample, 900 children, and find that the mean cost $8,275 with standard deviation 1,540.
Huge.
We're going to test this at alpha equals 0.05.
Let's do a claim.
Okay, let's rewrite the claim. Well, first of all, again, find the key word in here before we write the claim. And the key word is that the mean cost and sample 900. Those two things together tell you we're doing a large sample with mean. Come to this section of your note card.
Sample is 900.
Hmm?
You said 200.
Oh, 900. So, we're going to rewrite the claim. And the symbol for population mean is mu. And what's their claim? That the mean
That it's
cost
equal.
equal to 83.90. So is their claim the ho or the ha?
Oh.
That is the ho. So identify it. Ho. What is the ha going to be then?
The mean is not equal to 8390.
8390. There's the ha. So now we're going to sketch the rejection region. What is the ha telling me about my rejection region? Where is it at? What kind of test are we doing? Left tail, right tail, two tail.
I think it's two tails.
It is two tail.
How do we find out if it's a two-tailed? Is that in our other notes?
Yes, that was, if it's a not equal to, it's two tail.
Oh, okay, I see.
If it's less than, it points to the left. If it's greater than, it points to the right. So this is a two tail.
Ooh, a .05. You got a .025 on both ends, sure.
0.025 on both ends.
Why are we using ha?
Rich, Tort,
Yes?
do you always look at the
Because
HOD?
it's the one with no equal sign.
Do you always look at the HOD to find out?
Where the rejection is. Yep. And it's whichever way the ha is pointing. But this one's not pointing, so you got both of them, two tail. Like the other one was, the ha was pointing to the left, and it was left tail. If it's pointing to the right, it's going to be right tail. The ha tells you where your rejection's at. Okay, so if you do the inv norm of
Why are we using ha on this one though?
.025, what's that?
Why are we using ha?
We used ha on the last one also,
Yes, why?
because that's the way it works. That's the process. The ha
What
tells
is the
you,
process then? You just always use ha?
ha tells you where your rejection's at.
So on that thing, the only thing, so it's always gonna be true? I think like for the claim. how do we-
Oh, no, here the claim was the ha.
Yes.
This time my claim is the ho. So I'm going to be on the other side of the chart this time.
Why do we do that? Alright.
What's the inf norm of .025? Negative.
I expect in that case they didn't do it.
Yeah.
Oh, he's texting right now.
Plus or minus 1.96.
1.96. So and the other one's positive 1.96. And we got a 0 down the middle. It's a number line. Now we take our sample mean, turn it into a z-score, and see where it lands. So the z-score for our sample mean, here's our sample mean, 8,275. The formula says take the sample mean, subtract the population mean from the whole, 8390. And then your denominator is the standard deviation over the square root of the sample size.
Negative 2.24.
Sounds reasonable. She is correct.
I'm on fire.
And what does that mean?
Okay, that's where our sample is going to land on the curve. So I want to know, where is this negative 2.24 on my number line?
Projecting hoe on the left side.
So this is 0. This critical value is negative 1.96. Where is negative 2.24 going to be?
Left side.
More to the left, into this shaded region somewhere. Shaded means reject the hoe. If I had landed in the unshaded, I'd say failed to reject the hoe.
Where does that say that in the notes?
It was in Thursday's notes.
Oh. Reject hoe.
So shaded region is reject the hoe, unshaded is fail to reject hoe.
Now our claim is the hoe. So, this is
So we are
reject
going
hoe
to reject the hoe.
on a claim hoe.
So the claim, what are we going to say about the claim now?
Claim is false.
Claim is false. Okay.
It's false because the claim is the hoe.
Right, we're over there, yep.
Just like that.
Okay, so it's practice, this is by hand. Tomorrow we're going to do small samples by hand. And then Wednesday I'm going to put the two sections together, mix them up, and we're going to do programs that day. So then you'll have a chance to pick, should I be doing big or small? And this is programs, so.
Can you give us like 3 of these?
I am going to give you, I don't think they're all hypothesis testing here. Oh, I'm on the wrong thing, but, stats, okay. Page 324. Let me see what these are. I should probably just go right to there. I'm thinking, I got 4 of them.
Alright.
17, 21, 23, and 25.
Why did you just say 17 through 25?
I guess it is.
What? We don't have 19.
Well, you don't have 19. Matt?
Yeah.
Casey?
Do you even know how to count that?
Come on, Matt.
Yeah. No reaction. At all.
Okay, there you go. 4 of those by hand.
Let me guess, tomorrow's by program.
No. I already explained what I'm doing for the next 2 days.
Oh yeah, what are we doing now? 'Cause I won't be here.
We're doing small samples by hand. And Wednesday's going to be both by program.
How long, are the notes like the same thing?
Yeah, they'll be the same.
Same thing, just.
With T's. We'll be doing T's. Instead of doing inv norm, we're going to look T's up on the T table.
Is the T table on A20?
No,
it's both ways.
I think so.
I'm like.
It's in the front cover also.
Pressing on the X thingamabob is on the 20, A21.
Yeah, and then A20 is correct.
Okay. So I immediately like press on the brake, and then she starts screaming at me and beeping more. So then I just slowly turned,
So this won't be hard then.
and then she ended up just like
Gone tomorrow, I take it?
going around me.
Yeah. I think most likely.
She didn't like give me the finger. She didn't even look at me.
Oh, man, these are nice. They already wrote it out for you.
Yeah, that first one. Oh.
I did that the other day. I was going.
Oh, it's still going.